Hello, how are you? I have been asked to explain some descriptive statistics. This is Dr. Morote, and I will discuss how to evaluate the statistics, the normal distribution of your variables. In this case, we have a database regarding alcohol, and the first thing you will do with any database is trying to enjoy the data. So that means you need to understand what kind of data do you have. So this is the first time I see the database, so we are all in the same page right now. I see there is a rating. You see here values. I am in variable view, and then here I explore my data. I see, oh, very good, good and fair. So I can see what kind of data you have. Then you have countries here, so that's a nominal data, and you can see here ordinal, nominal, ordinal scale, regional and national. Okay, good. And then we have calories, then we have alcohol by volume, price by class, and all of these C are the C scores of all of the same variables that we have here. So going for the question that we were discussing, we have a question which is here, activity 4.18. In this question, they ask you to run the frequencies of this, do the histogram for normal curve, and then evaluate about the mean and the median, and then how these differ from the normal distribution. So we will try to answer these three questions, which is basically checking if a variable is normal distributed. So you need to understand your variable. And they ask to use the variable alcohol. So I said, okay, good. Here is my variable. Where is alcohol? Here it is, alcohol. Perfect. I used highlighting up something where it is. So you go analyze the scripted frequencies. That's pretty straightforward. I already moved this, let me reset. And then here's the alcohol. And then I go to statistics here. What's the mean, median, the distribution will be skweness and kurtosis. And I will check the standard deviation, the minimum and the maximum. Let's see what they go. Now in charts is where you actually see the histogram, and then you put the normal curve, so you want to see how close it is with a normal distribution. And voila, we just click OK. And we have here the data. So I can see very quickly the mean and the median are not really close, so there is some differences. And then when you go to a skweness, is -2. So without seeing the graphic, I can see it will be skew to the left. The kurtosis is also high, so there's a kurtosis, there's a point of this, and the meaning of the maximum. So then I go and see the graphic here. If you see the graphic, you see the skweness was negative, and as you can see, there is still some is sort of skewed to the left. Now, what that means, what exactly that means? Well, it means the following. I have here a website. So that means you see here negative, so that is skew for this side. If it was positive, it would be skew for the other. So it's not really a normal distributed variable. We may have to do changes, maybe not, depending of the following steps that will follow. They will do. And also we learn that in order to have a normal distribution, we will expect to have the variables very close to between -1 and 1. So here's the interpretation. This was based on Bulmer 1979. It's just a rule of thumb. If the skweness is less than -1 or greater than -1, so it's between, is outside of -1 or plus -1, then we're talking about a distribution that is highly skewed. So we will have a problem with that. If this between -1 and -0.1, will moderated skew, we can live with that. And usually if we have -0.0 between plus 0.0 will be a sort of symmetric. So we will look for a symmetric. My rule of thumb, if you have something between -1 and +1, I feel comfortable with that. So that was one of the questions. The other question where you have here is who is higher? Well, you can see the median is higher in this case, and you can see it's skewed, negatively skewed. So we may have an outlier here, but we need to test it, and we will see how to test it later. So that's it. It's very simple how to understand if the variables is skewed or if the value have a peak in the kurtosis.